Okay, so this is symmetry of two-dimensional shapes. We're going to talk about the shapes a little bit and the symmetry of it a little bit. Let's think about this, okay? The first thing that we're going to try and figure out is whether or not we can identify the shape. It says a figure is a blank. Well, we know it has four sides, so it's a quadrilateral. Okay? Oh boy, these are all quadrilaterals. So let's talk about the different ones. The first one that we have listed here is a square. Well, to be a square, it's going to have to be a rectangle, and it's going to have to be a rhombus. So let's check for if it's a rectangle first. Now, rectangles have 90-degree angles, and so what we'd have to do is see what the slope is here and what the slope is there, and we should be able to multiply those out, and they should equal -1. So my slope, to get from, let's say, this point right here, and this looks like -6, -3, to get up to, what is that, -2, +9, there would have to go to the right 4, right? So my run is 4, and my rise, I'd have to go up 12. So 12 over 4, and that's a positive slope. So 12, rise of 12 over 4, so my slope is 3. So now to get from this point down to that vertex, so this is again 2, -2, +9, I'd have to go down 4, so we're going down 4 over, go all the way out here to 10, that would be 12 as well. So my rise is -4 over 12. So 12 over 4 is my rise and run this way, and -4 over 12 is my rise and run that way. If I multiply those together, 12 over 4 times -4 over 12, my answer is -1. And that is a proof that these are perpendicular lines. So what is this run? Well, it's a rise from this point to this one. This is a rise of 12 again, and a run of 4. So I know these two are perpendicular, and if these two are perpendicular, I'm going to guess this last one is too, right? We're just going to check it. This one has a, let's see, it goes from -3 down to -7, so it has a rise of -4 and a run from -6 to +6, so that's a run of 12. So again, has the same rise and run as the opposite side. So I've just proved that to myself that this is perpendiculars, right? And that this is I know that they're parallelogram because the slopes were the same. So I know it's at least a rectangle. Now, how would I know the whether or not it's a square? Well, the square is going to have, you know, all sides are going to be congruent. That's what a rhombus is. A rhombus has 4 sides that are congruent. And, you know, really, I know that if the rise-run triangles that I formed are all identical, then I know that the lengths here are going to be the same, right? And this was a rise of 12 over a run of 4. So the hypotenuse of that little right triangle, the rise-run right triangle, the hypotenuse here, which is this edge, is going to have the same length as any other one that has a leg of 12 and another leg of 4, a leg of 12 and another leg of 4, a leg of 12 and another leg of 4. So I know all 4 sides are going to be congruent. So that tells me it is a rectangle, it is a rhombus, it is a parallelogram, it therefore is a square. That is the best option, right? It's the most specific. Now, what's a trapezoid? A trapezoid is just where you have exactly one pair of parallel sides, and then the others are not parallel. So you could have a side like this, and this side would come in, you know, kind of at an angle, maybe something like that. But the top and the bottom, sometimes they call them the bases, would be parallel, and these legs, they would call them the legs, are not parallel. This is not a trapezoid. And then a kite has 2 sides that are congruent, and then there are adjacent sides that are congruent, and then the other pair of adjacent sides are also congruent. But they are not opposite sides congruent, they are adjacent sides that are congruent. So this is not that either. Okay, so we know this is a square. So now we're going to try and answer this question. Select all that apply. If we reflected this over the line y equals 3x negative minus 5, would it then leave the figure unchanged? Well, where is the line y equals 3x minus 5? Well, 3x minus 5, so it would cross the intercept here. It would have a y-intercept of negative 5, so it would cross the y-axis at negative 5, and has a slope of 3, so we would go up 3 over 1, right? Now, what's interesting about this is, remember that we had a rise of negative 4 and a run of 12. And so halfway, the midpoint would be a rise of negative 2 and a run of 6. It happens that this intercept is right at the midpoint. So I'm suspicious. I think this probably could work. But anyway, 3x minus 5. And what I would do is I would say, okay, let us rise 3 to 2, negative 2, and go over 1. And we'd rise 3 more to negative 1 and go over 1. And this would be on that line too, right? Then we'd rise 3 more and go over 1. And then we would rise 3 more and go over 1. Now this point right here, turns out, is the midpoint of, that's the point here, 4, 7, and it's the midpoint of this opposite side. And I know that because the full rise from one vertex to the other was negative 4 over 12, and so actually this would be a half rise to negative 7, 4. We would have moved down to over 6 to get to negative 7, 4. So my answer would be that one. That one would definitely work. Now, I'm going to pull it up in Geogebra to verify because I like getting things right. But we'll do that right here in a minute. Okay, so I'm going to test this out now. I'm going to put my vertices in. All right, and my first vertex was, I'll put capital A equals negative 6 comma negative 3 and hit enter. And my next one was at B equals, let's see, negative 2 comma 9, enter. And then C equals, let's see, 10 comma 5, and D equals 6 comma negative 7. So I just quickly wrote those down right here so that, you know, as I want to finish this problem, I can just look at this page to do it. And I'm going to make my polygon, okay, which was the one we identified was a square, and we could confirm that in Geogebra very quickly. But we're not going to do that right now. Boy, that doesn't look like a square, does it? To me, man, my eyes are getting goofy. Oh, when I change the scale here, okay, so to make it all fit, I kind of changed the scale. And if you change the scale, it can definitely throw things off. And this is why you can't really trust your eyes when you look at things, because they can look goofy. Okay, we're going to put this equation, or the line in now. So the line was, let's say, y equals 3x minus 5. We put that in. It does appear to be symmetrical to that line, meaning that, you know, the line cuts it in half in a way that there's some symmetry here. And so let's try reflecting the object about the line. Okay, so we're going to reflect the square across that line. And as you can see, all of the points are a match. All the segments are a match, and all of the points, right, this one ended up here, they're all matched up. So we could definitely go in here and say that that one is correct. How about y equals negative 2x plus 5? Well, I'll just put that line in there. Y equals negative 2x plus 5. And I wonder if we could do that. Let's try reflecting. Hit escape here. We'll reflect the polygon across that line. And what do we get? Well, we got it again. Everything is lined right up. So we can say that that's correct. Okay, we'll go back in here. How about a reflection over the line? Y equals 1/2 x. So we will go y equals, and I put 0.5x. That's just a little bit easier. Boy, that looks like it's going to reflect. So, but before we, guess, let's just go ahead and hit the reflection button, and we'll select our quadrilateral over that line. And our fourth quadrilateral is all lined up perfectly. So we're going to say yes, that also does it. Now it says, how about a rotation of 180 degrees about the origin? Well, that means 180 degrees, I go clockwise or counterclockwise, but this point is going to end up down here, right? 9, 5 is going to rotate all the way around until it gets to 9, well, that's 10, 5, sorry, until it gets to 10, 5 down here. So I do not believe that's going to work. So I'm going to leave that one alone. A rotation of 90 degrees around point 2, 1, 2, 1. Well, the only way to do that for me, to be 100% for sure, and there are geniuses out there, and they seriously, you know, everybody's smart in different ways, okay? But one of my most impressive smarts that I see in people are the ones that have spatial awareness. And they actually, it's a level of intelligence called spatial awareness, and they have a great understanding for space, and they can just look at things and they know how things work out. Me, I often like to verify, and that's what I'm going to do here. So we're going to rotate this 90 degrees about 2, 1. So I better put in 2, 1. So we'll call this point, I don't know, let's call it point E equals 2, 1. Okay, and we hit enter. Ah, look at that. It happens to be like right in the center of all those lines. Something tells me this might rotate. But to be sure, we were supposed to go 90 degrees. And it doesn't tell me counter or clockwise, but it's positive. You might remember I told you when it's positive, in general, the general rule is positive goes counterclockwise. So here we go. We're going to hit escape. I'm going to do a rotation of my quadrilateral around point E, and I need to go 90 degrees, and I'm going to go counterclockwise. And as you can see, boom, we're right back where we started from. So that one looked good, and now it says a rotation of 180 degrees. Boy, I think that's going to work too, but let's go ahead and just confirm. So we hit escape, and here we go. Oops, sorry, here we go. We're going to rotate this polygon around that same point, and now we're just changing the degrees, 180 degrees. And guess what? If you're going 180 degrees, that's halfway around the circle, so it doesn't matter which way you go, counterclockwise or clockwise. But we'll stick with it counterclockwise for now. And you can see, boom, it's all right there lined up. So that one is also going to work. Now we'll go ahead and we will check this answer. Okay, we're going to hold our fingers and hold our breath, and yes, we got it correct. So that's how you're going to do this set of exercise like this, and you got to get 5 in a row correct. So go